So where am I going with this thread? And I want to bring you to the two main papers of the last couple of years. The first was the paper in 2009 from Lombardi, the Urisman paper. This is the original paper in PNAS on XMRV. Now, XMRV was isolated as an infectious virus from prostate cancer and chronic fatigue syndrome patients. XMRV isolates are very similar in sequence, and that for a retrovirologist also is a little bit of a red light here with XMRV. It can mean one of two things: either this virus does not replicate very rapidly, or we're looking at contamination. XMRV forms a distinct clade amongst the xenotropic murine leukemia viruses, the proviruses. The second paper is the most recent one by Lowe et al. That was in PNAS this year. This was detecting polytropic MLV, detecting virus sequences using primers to the murine leukemia virus gag and envelope proteins. They identified MLV-like sequences. This was found predominantly in CMS plasma, and again, this is a very important point here, that no infectious virus was reported in the Lowe et al. Study. They're looking at viral fragments, and only bulk sequences were reported in this paper. An important point, we're not saying at the moment that there is a major problem with this publication, but an important point is that unless the relationship is further clarified, we must consider the XMRV study of Urisman, Lombardi, and others, and the MLV-like sequences as two unrelated phenomena. They should not be grouped together. Okay, precautions moving forward. Again, we're saying XMRV may be important in the etiology of both diseases that have been reported, but there still are conflicting reports on the association with either disease, and there's a lack of insight into the pathogenic mechanisms. Here again, some studies may be complicated by trace contamination with mouse DNA. And maybe if I just go on one bullet here, it makes the point. One mouse cell contains approximately 100 polytropic leukemia viruses and xenotropic murine leukemia viruses. Sensitive PCR assays can detect the provirus in 10 femtograms of mouse DNA. Now, this is when the slide came up at the meeting that confused a few of the reporters, where John Coffin showed his swimming pool. They could not understand the rationale of John's swimming pool getting into the meeting. John has a reasonably sized swimming pool. His analogy was, if he put one drop of mouse DNA into his swimming pool, the technologies we have to detect that, would detect that. In 1 milliliter, we don't have to analyze his whole swimming pool, 1 milliliter from John's swimming pool, he could detect the mouse DNA. And that's just to make a point of the exquisite sensitivity we have with PCR. And that is the advantage of PCR. That is also the disadvantage of PCR, how easily we can pick up contamination, and how important it is to make sure that when we're talking about XMRV, we are talking about XMRV, not polytropic viruses, not mouse mitochondrial DNA, not intracisterna aparticle DNA. We have to be extremely cautious when using these assays. I think that is a long way of what John put in one bullet. Okay, this was the second more controversial point of the meeting, the use of antiretrovirals with XMRV. There have been reports, XMRV, like murine leukemia virus, it is sensitive to a limited number of antiretrovirals that have been used for HIV. AZT affects the viral polymerase. Raltegravir affects the viral integrase. These have been shown to be effective against XMRV. There have been reports of off-label use of some of these compounds in CFS patients, with anecdotal results published. John made the point that we are not against a well-controlled clinical trial, but there are several provisos before going forward with a clinical trial. We still don't know whether XMRV is causal. The drugs only work by blocking replication cycles, not repairing damage that's already caused by virus replication. This brings me back to one of my earlier points, that we see very little sequence diversity in XMRV. Now, one reason could be, like HTLV, XMRV does not replicate very fast. If it's a very slow replicating virus, this has significant implications for antiretroviral therapy, which are based on a virus which is replicating very fast. And so simply because AZT and raltegravir work against HIV, I think we have to be very careful about jumping with those two. Now remember, the success of HART, or highly active antiretroviral therapy, is using a number of antiretrovirals against a number of targets, and sometimes two antiretrovirals against one target. What we have here, the antiretrovirals currently will not affect XMRV protease. The so-called non-nucleosides will not work against XMRV. 3TC, which is another anti-HIV drug, will not work against XMRV. We have a very limited cupboard to go to at the moment. I always say in HIV research, the goal is always, when we go back to the cupboard for another antiretroviral, to make sure there's something in the cupboard. It should never be empty. Our cupboard here is 2 compounds at the moment, and I think we have to be very careful before moving into antiretroviral therapy. The disease also lacks objective biomarkers to monitor treatment. We have no appropriate assay. I'll be talking today about the various assays that are being developed. There is no standardized assay for viral load or P20 equivalent of HIV P24. The results of the studies that have been done anecdotally, they will not be accepted by third-party payers or regulators. And these sort of studies will keep the treatment out of the reach of a large majority of people suffering from CFS. And so again, let me just reiterate, we are not saying there is no logic to antiretroviral therapy. We're urging extreme caution. We can't move forward with antiretroviral therapy based on anecdotal results from CFS patients. So this was the talk. This was the second talk from someone in John's lab, and again, I'm repeating a theme here about XMRV elements in mouse genomes. This is Dr. Chingos, I believe, from Tufts University. They have developed a highly specific PCR assay to screen for XMRV-specific sequences in mouse genomes. They tested 75 wild-derived and inbred mouse strains, and so far they find XMRV-like sequences in 13 mouse strains. A single genome assay-based, single genome analysis assay, this is again a highly specific assay, to distinguish MLVs based on their gag leader region. Fragments from 7 strains were isolated. So far, 2 strains have sequences with the gag leader deletion that's common to XMRV. Genomic hybridization blots on mouse DNA with XMRV-specific probes. 10 mouse strains examined, 6 so far have the same insertion. So what you're seeing here is how easily we can detect mouse DNA with PCR probes that are supposed to be specific, that are specific, or we thought were specific for XMRV. And again, reiterating this point, that contamination is an issue that we have to take very seriously here. This, probably you don't see this, but the last point that was brought up in this talk was intracisternal A particles. These are endogenous retroviral elements of mice. They're sort of like retroviruses in disguise. They don't have an envelope gene. They're defective particles that accumulate in the Golgi. There's about 1,000 copies per haploid genome. And these form the basis for a very sensitive and highly sensitive assay for detecting trace amounts of mouse DNA in your sample. And again, this was a theme that was threading through the meeting now, that we need to have highly specific assays for the potential for mouse DNA contamination. Mouse mitochondrial DNA or intracisternal A particles. These are never found in humans, intracisternal A particles. And the second talk during this period came from Dr. Huber at Tufts University that was strongly implying that the presence of intracisternal A particle DNA in samples. This has not been published yet, but the implication has been made.